Welcome to the lecture for section 9.3, and in this lecture we're going to be talking about perimeter and area. This is for MGF 1106, Liberal Arts Math, and my name is Jorge. So the objectives for this lesson are the following. We're going to go ahead and calculate the perimeter and area of geometric objects. We're going to understand how area formulas for geometric figures are related. We're going to go ahead and use a Pythagorean theorem to solve problems involving right triangles, and then we're going to calculate circumference and area of circles. So the first thing is, let's look at some definitions. So the perimeter of a polygon is the sum of the length of the sides of the polygon, and the area is a measure of the amount of the surface that the polygon covers. So here we have a rectangle. So the perimeter and the area of a rectangle is the following. So if a rectangle has length, that's L, and width, that's W, then the perimeter of that rectangle is going to be P equals 2L plus 2W. And then the area is simply the length times the width. So here we have an example. The length of this rectangle is 6 feet. The width is 4 feet. So then the perimeter will be 20 feet because it's going to be 2 times 6 plus 2 times 4. And then the area is 24 square feet because it's 6 feet times 4 feet. Now the next thing is the area of a parallelogram. And the formula for that is A equals H times B, where H is the height and B is the base. The next formula is the area of a triangle. A triangle with height H and base B has an area that's 1/2 the height times the base. So in this case, if you have a parallelogram, we can go ahead and divide that into two triangles, and that's why the formula is 1/2 the height times the base. So here's some good advice. If you practice deriving the area formulas we have developed, it'll be easier for you to remember the details of the formula. So for example, remembering that a triangle is 1/2 of a parallelogram helps you recall that there is a factor of 1/2 in the formula for the area of a triangle. So here's an example. Recreation area is in the shape of a parallelogram. If a pound of grass seed covers 100 square yards, how much grass seed is needed to seed the entire area? So here we have 70 yards is the base of that one triangle, 130 yards is the base of the second triangle, and then the height is 150 yards. And then the total distance from point C to point B is 200 yards. So then the area would be 150 times 200, which is 30,000 square yards. And then we take the 30,000, we divide it by 100, and then that we get 300 pounds of seed. Here's another example. If a pound of grass seed covers 100 square yards, how much grass seed is needed to seed only the triangular area ACD? So we only want to cover the triangle that's shaded. So it's 1/2 the height times the base, so it's 1/2 times 150 times 70, which is 5,250 square yards. We take that number, we divide it by 100, and we get 52.5 pounds of seed. The next thing we're going to look at is Heron's formula for the area of a triangle. So suppose a triangle has sides A, B, and C, and we define this quantity as being S is equal to 1/2 the sum of A, B, and C. Then the area of the triangle then is the square root of S times S minus A times S minus B times S minus C, where A, B, and C are the sides of the triangle. So here's an example. A gardener wants to fill a triangular flower bed with flowers. Now the gardener estimates that he will need 4 bulbs for each square foot of the flower bed. How many dozen bulbs should he buy? So here we have that C is 24 feet, B is 12 feet, and A is 18 feet. So using the formula, we get that S is equal to 27. And then we use that information and then the sides to plug it into Heron's formula. And we get that the area is going to be the square root of the product of 27, 9, 15, and 3, which we get that's approximately 105 square feet. Then we multiply that by 4, and we get that it's 35 dozen bulbs. Next thing that we're going to look at is the area of a trapezoid. Now a trapezoid with lower base B1 and upper base B2 and the height H has an area that's equal to 1/2 the sum of the base, the sum of the two bases times the height. Here we have the upper base, the lower base, and the height. So here's an example. A platform for a statue will be formed by joining 4 congruent trapezoids and 1 square. Use the formulas we have developed so far to determine the surface area of the platform. So the first thing is that the area for the top is going to be 4 times 4, which is 16 square feet. And then the area of the sides will be 1/2 the sum of the bases times the height, which comes out to 10 square feet. So then the total area is going to be 4 times 10 plus 16, which is 56 square feet. The next thing is a theorem that we've all seen, right? So if A, B are legs of a right triangle, and C is the hypotenuse, which is the side opposite the right angle, and here is shown in red, then A squared plus B squared is equal to C squared. So let's use this theorem. Use the length of the two given sides to find the length of the third side in the given triangle. So if you notice, what we're missing is the hypotenuse. So we're given that A equals 8 and B equals 6, and using the theorem we get that C squared is equal to 8 squared plus 6 squared, which is 64 plus 36, which is 100. So C squared is equals to 100, so then we have to get the square root of both sides, so C is equivalent to 10 inches. Here's another example. Here we're given that A is 15, C is 16. So in this one, we're given the hypotenuse, we're just missing one of the legs. So 15 squared plus B squared equals 16 squared, and that's just the theorem that we have. So we're going to go ahead and solve for B. So 15 squared is 225, 16 squared is 256. And then B squared equals 31, and then we get the square root of both sides. So B is approximately 5.57 meters. So here's another example. The Great Pyramid in Egypt has a square base measuring 230 meters on each side, and the distance from one corner of the base to the tip of the pyramid is 219 meters. So what is the height of the pyramid? So the distance to the center. So we're going to go ahead and solve for x. Now here we have a right triangle. So x squared is equal to 115 meters squared plus 115 meters squared, which is 26,450 square meters squared. So then x is just a square root of that, which is approximately 162.6. Now the height of the pyramid, using the information that we just had, we're going to go ahead and use the fact that 219 meters is equal to 162.6, which is, we derived that from the 115 square roots of 2. So we square that plus the height squared. So we're solving for h, and we get that h is approximately 146.7 meters. Next thing is circle. Circumference and area of a circle. So a circle with a radius r has circumference c equals 2 pi r, and the area is a equals pi r squared. Now a number pi, which appears in these formulas, is the Greek letter pi, and we'll use 3.14 to approximate pi for this class. So here's an example. A man is designing a basketball court in the form of a segment of a circle. There will be a fence at the rounded end of the court, and he will paint the court with a concrete sealer. How much fencing is required? So we're looking for the fencing here. So the court is 1/6 of the interior of a circle with a radius of 20 feet. So the circumference of the full circle is 2 pi r, which is 2 pi times 20, which is 40 pi, which is approximately 125.6 feet. And then 1/6 of that is 20.93 feet. Now, here goes. A man is designing a basketball court in the form of a segment of a circle. There will be a fence at the rounded end, and he will paint the court with a concrete sealer. What is the area of the surface of the court? So now we're looking for the area of the surface of the court, all the gray area. So again, the court is 1/6 of the interior of a circle with a radius of 20 feet. The area of the full circle is pi r squared, 400 pi, and that's approximately 1,256 square feet. 1/6 of that is 209.3 square feet. And that's the end of section 9.3. Thank you.